Right, so just gonna take this apart so you can see what's on the inside first before I start building this generator. So what I want to use this for is for a wind turbine. This is actually a DC motor, as you can see here, hooked up to some gear combination. So just gonna take this apart so you can see what's on the inside. All right, I think I'm gonna need some lights or stuff or something to put that down there, just like that. Right. So we're gonna open this up and whoa, be careful. So don't take. All right. There it is. So we've got sets of gears to increase the torque. So this is it. So we've got here a small gear, much bigger gear, much bigger one, and then this one is making this move really fast. So here's what happens. The numbers of teats on this gear, see, when I move this a bit, the numbers of teats here turns and makes this one go faster, right? So let's see. The speed on this one has been increased, and then when this one turns this one right here, the same thing happens. The speed increases. And to the last one right here, the speed increases. And then when this is used as a generator, as you can see, when we turn, it increases the speed from this point to this point and then here. But when this is used as a motor to drive, I don't know, anything, the torque becomes more powerful because when this guy turns, torque increases from here, and then here, and then here, and it continues just like that. So we're going to use this to build a wind turbine. Yep, today. And yeah. So let me take this apart so we can see what's inside. Oh, okay. Just take this. There's a lot of this. See, they've rubbed grease on the thing. Whoa, damn it. All right, so yeah, I think there was something holding this. Well, never mind. Just put that there. So we're gonna couple this back again. As you can see, it's not much. Just you want to increase a torque. You want to build a robot, right? If you want to build a robot and then you want to increase a torque, you want to make the robot more powerful, like the joints, like move more powerful. You're gonna need this combination of gear. It's not much. You can like 3D print these gears, or you can just fabricate these gears yourself by using maybe metal, or you can use a circle metal disc, and then you can just cut the teats on a lathe machine. So as for this one was I think produced in a factory where they use injection molding machines. So let's put this back together and then we can build the wind turbine. So couple this, put that right there, and then look at what happens. Well, I think I need to cover this up. So this is the cover right here. Just cover this up right there. There we go. I'm really sorry about the quality of the video, guys. I'm just using one light above to film, so let's just couple this back so I can run it, and you can I can test this out with my multimeter, and you can see how many volts this is going to generate. Oh, I think I'm missing something here. Yep. Oh yeah, this one, like this. And let's try and cover this. What is going on? All right. Pull out this one first. And then, let's see. I think, oh, this goes first. This one goes first. Yeah, that was a mistake I made. So this one goes first. Let's see. And then this, right? Nope, this one goes on there. Is it? No, here. All right, there we go. There it is. And this one is here. All right, so here it is. What is happening? Oh yeah, we need to center this because right now there is no metal holding this, so this is it right here. So this one is just moving, spacing itself away from the teeth here. So I'm just gonna copy this back so that we can generate electricity. So you can hear that. Yeah, I made a hole here where I can just use a screwdriver to turn it. So let's couple this, just put the screws first, and then we can see how many volt this is generating with a multimeter. Well, the thing is, it'll be much better if you use a brushless motor, because with the brushless motor you can generate AC and then rectify it with, let's say if it was a three-phase brushless motor, we can create a three-phase rectifier, which is really simple. I'm going to show you that the diagram in a moment. Let's just measure the voltage of this guy first with a multimeter. Right. Oh, it's broken. All right. Turn that to 200 DC. Whoa. Right. So we're going to measure the voltage and see how many volt we're going to get from this. So let's see. Connect that right there, and then this one goes right here. Okay, there it is. So we hook this up, and now we're gonna spin it and see how many volt we're gonna get. All right, put this. Oh, yeah. I'm gonna miss it. Oh, no. No. This way. Whoa. Dude. All right, I'm just going to use my hand to turn this. 30 volts. 30 volts, guys. Let's see if we can go more than that. Let's see if we can go like 37. You know, it's really hard to turn this, but when I hook this up, when I hook up the blades on the wind turbine blades, we're gonna get more. I mean, if only the wind is strong, we're gonna. Let's see. All right. The max I got from turning this with my hand was just 30 volts. So let's. Yeah. So this is the same motor. We've got like 3 of these guys. You know, actually, I was gonna build a rover with this because this motor has a lot of torque. It's really hard to stop it when it's in motion. It's really hard to stop the motor. If you just put your hands here, it's gonna break your hands, your fingers or something. So, I took this out. I had taken this out. The same thing, guys, but this one has much bigger gears. This very one has a much bigger gear, and just, I think the same 3, and then the motor was right here. So you can see it becomes really fast at this point, And when I turn here, it's really slow, which means the torque at this point will be increased. As you can see, I'm holding this, but it's still turning. But when I hold here and turn, it's really hard. You know, I can just stop this with one finger. See? It's really hard to stop it, but I can use one finger to turn this. I'm gonna hold this really strong. Okay. As you can see, it's still turning. So when we turn here, the torque increases way more stronger. But at this point, it's just really fast, but really low torque. All right, so couple this. And then we're gonna power something with this guy. Let's see if we can power, I don't know. Okay, let's use it to power this other motor first, before we move on to other things. So just gonna hook up this first. All right. So if you're new to this channel, you can support the channel by hitting that subscribe button. If you like the video, you can also support us by hitting the like. All right, so I'm just gonna hook this up and then, all right. So what this channel is all about is electronics. We do more of electronics, science, mechanical videos where we weld and fabricate stuff. All right, so this is what we're gonna drive, and let's see, and let's turn the motor. All right, let's see if it's gonna turn. Whoa, it's really hard this time. Yeah, the reason why is because this one consumes a lot. So first, okay, let's measure the current first. That's the most important thing we should do. Let's measure the current on the multimeter so we see how many amps we're getting from this. So now we're gonna measure the current, and then let's see how many amps we're gonna get. And then we're gonna do some calculations so we can know the wattage, how many watts we're getting from this generator. So first, I'm gonna hook up the terminals, and then I'm gonna tune to 20 right there. Yep, place this so you can see exactly what I'm doing here. Reflection is not. All right, so turn this with my hands. Yeah. That is really hard. That is really hard, guys. Well, it's really hard to turn. All right, let's try something. Let's use a, what exactly? Let's try that again. It's really hard to turn because the resistance here is, let's see, let's measure the resistance. Oh, that's still connected. So here it is. So we got 4.6 ohms. And this cannot power this motor right here because I'm using, let's see. Yeah. What I'm doing isn't right. So, right, let's power something else. Let me get an LED or something. Or something much. Or maybe we can charge a battery or something and see if it's going to do a great job at charging the battery. Yes, let's start a battery. We need some wires. Get some wires first, and then let us charge. First, I'm going to carry this out first, and then connect these. All right. So we're going to use this generator to charge this battery by just hand crank. So imagine, okay, just hold on a sec. Let's connect this and see if we're going to get, if it's actually going to charge the battery. Let's see. So first we're going to measure the voltage of the battery, and then we can start charging. All right. Where did I put my wires? Come on. Right. Put my wire. That's a blue one. Yeah. I mean, that's a wrong color code. I'm hooking this up to. Well, anyways, it doesn't matter. It's just a conductor. But the thing is, when you're doing a wiring project or anything, you should do it correctly by using the correct color code so you wouldn't confuse anyone that's going to repair or troubleshoot your work. So it's better to use the wrong color code for the right terminal. I mean, for anything you're doing. So yeah, let me just correct myself here. The positive wire, which is red, is going to go to the positive terminal of the battery. So okay, and then black. Yeah, I do have black. So the negative, always the black one. But it doesn't really matter. It's just a conductor. So, but you should always do the right thing by using the right color code for any of your projects. So guys, if you're enjoying this video, hit that like button. I mean, I'm not seeing it. May I activate any of it? Let's see. All right, so we're gonna hook up this. Yeah. All right. Okay, so let's measure the voltage. Bring this guy in, and reflection is just killing the camera. So, all right, 20, yeah. All right, let's measure the voltage. So okay, let's just do this. So we've got 2.59 volts. So we're gonna hook up our multimeter, and then we're gonna hook up this guy. And as we're charging, it's gonna display on the multimeter if it's actually charging or not. So let's hook this up. But the thing is, we're gonna need a diode for this. So let me grab a diode. It's gonna be really hard to find, but let's just see if I can find a diode on one of these components. I've run out of diodes completely. Just let's see if I can find any rectifier or anything. Anyway, the thing is, if I hook this battery up to the generator, it's gonna. Let me show you. It's gonna run as a motor instead of a generator. But if I hook up a diode, it's gonna stop the voltage from the generator coming into the battery. The battery. Sorry, it's gonna stop. It's gonna stop the voltage from the battery. The voltage is coming from the battery to the generator. So let's hook this up, and as you can see, it's turning. So it's not really good. If you're charging a battery, it's not. You don't want to do this. So you want to hook up a diode in series with the battery and the generator. So just hold on. Let me grab a diode, and then I'm gonna hook it up to the generator so we can see the charging effect. Come on, where did I put all my diodes? Davis. All right, can you help me with that? No, not this one. Right, so I've literally run out of diodes, guys. But I can use a rectifier. Let me just check if I'm pretty sure I have one of those laying around. One of my power boards, I think I should have a rectifier. That the rectifier with 3 terminals. I think I should have one of them laying around, so I'll show you exactly how it works. Come on. Where did I put it? Well, it's always really hard to find. Alright, so I'm gonna send my brother to go buy it right away. I'll be back, guys. Here's while you're buying it down, the story, you get the story back. Yes, I'm bringing that this far. Just help me buy it. Right. Okay. Right, guys. So I've sent for a diode. So I'm gonna power a pump that I built with this. Let me get it first. So this right here is an air pump for a stove that I built. This is for a rechargeable charcoal stove. So what is in here is just this 9-volt DC motor, and then the propeller in there. Is it a propeller or an impeller? So it just pushes air through this hole, and then there is a pipe where you're gonna fit it into the stove, then use it to cook. It's a really fast cooking stove, and you can use it as a furnace as well. So I've sold a lot of this online. No, this one right here is just a prototype. But the main thing, I've sold a lot of this, guys, and I've got a lot of good comments from this. So let me power this up with the battery first. You can see. Oh, let me just stabilize this first. All right. So, okay, pick this up. As you can see, let me just, whoa, there was sand in there. Let me get something like a paper so you can see that is actually, oh, it's actually spinning. Okay, gotcha. We're gonna use a polythene bag. All right, so as you can see, we've got some air. So now we're gonna use the generator to power the pump instead of the battery. And when we've gotten the diode, we're gonna use that to charge the battery. So connect this and connect this. If you like the video, give us a like, please. All right, so, oh, message. Whoa, did you see that? Wow. Whoa. Okay, let's do this. All right, put this right here. Okay, so watch what happens when I turn. Okay, that's not moving. Put in the direction right there. All right. Whoa, that is really fast. All right, place it right here. Okay, let me just place this right there inside, and then when I turn, whoa. Sucked it in there. Come on. right, place it like this. There it is. All right, we're gonna turn. Whoa. I mean, you can turn. Yeah, so the thing is, let me get a pen so I can draw and show you guys what the rectifier looks like. Where did I drop my pen? Where is my pen? Every single thing in this room is just missing. I can't find a diode, I can't find a rectifier, now I can find. Alright, okay, so the rectifier I was talking about, the 4-terminal rectifier, which has the 2 middle terminals are the where you're going to hook up your where AC goes in, and the other 2 are marked as positive and negative, where the output, which is the output. So if I hook this up to the part where where it has a sign of an AC sign, even though I turn in different directions, and if it's hooked up to this, if this is hooked up to the rectifier, and then the rectifier is hooked up to this pump, if I turn it in different directions, this pump is still going to turn in the same direction. I can't actually remember what that is called because, all right, so I can't position this so you can see what's going on. Never mind. All right, but this takes a lot of power to push something. Okay, so what should I do next? Let's yeah, let me show you a project that I'm working on. Right. Okay, I'll be back. Right. So this right here is a stove. It's a kerosene stove I've been working on. But the thing is, it smokes. So what I want to do is I want to build a catalytic converter that's going to convert all of that smoke into clean and neat fire. So I don't have the materials for that right now, but there's going to be a video on that, because I want to use this to warm, because right now it's a raining season, and I want to use this to warm my chicken's house, my chicken coop, most people call it. So let's light this up. As you can see, it smokes really terrible. So you don't want any of this fume going. You don't want the chicks breathing any of this fume. So in my video, I'm going to build a catalytic converter that's going to convert all of that smoke into clean and blue flame. Yeah. So let's get on to the generator. Oh, this guy. Well, anyway, let me just search for that, for the diode. Okay, where did I put that diode? You know, I usually salvage my components and then put them in a box, but I can't find the box. Okay, so let's use the generator to power this 12-volt DC motor, which is really fast. Let's see if it's going to turn on. Okay, hook this up. And connect this. Okay, drop it there. So you can see. Okay, I'm gonna put this right here and then turn. Oh, stay. Come on, like this. Come on. As you can see, it's spinning. All right, let's keep it this way because the air is going through this direction, and then let's drop this right here. Yep, it's spinning. If you like this video, give us a thumbs up. Give the video a thumbs up if you like it. All right, turn that again. All right. All right. Reverse. Okay. Let's do something else with this. I mean, we can charge a phone with this. Hold on a sec. Let me get. I have a. I do have a converter right here. Is it still here, or did they take it out? Come on. Can't find it. Can't find it. Catalytic converter. Story. Can't find the thing. Right. The light is not as bright as I was thinking. Right. Let's see what we can do. All right. Good. Oh, good. Where did I put it? I can't find my rectifier, and I also can't find diodes, and also my converter. Well, the Russians say. I don't know where did I put it. I can't find my. All right. Come on. Okay, guys, let's do some calculations. Let's see. Guys. Okay, let's talk about the wind turbine setup. So, to run a wind turbine, to get a lot of energy for a wind turbine, and you just hook up a motor like this with long blades, you're not going to get much energy, because what's going on is that the blades are turning. It looks like the blades are turning fast, but it's not really spinning the motor as fast as possible. So what you need is a combination of gears. As you can see here, you're going to need a combination of gears to turn. Just like this one here, we have to we need a lot of power at this point. You do know that wind has a lot of power. And if you stop the wind by using some blades, you're going to get a lot of power from that. And then when this spins, it's going to increase the speed at this point, just like I showed you guys. Let me open this up again. This right here is the same thing that's on this guy. So when this one turns, let me arrange this first so you can see what I'm talking about. So when this guy turns, as you can see here it's slow, but at this point it's much faster. So when the wind turns, slow, even though it's slow, we're gonna get much faster. We're gonna get a lot of speed at this point, but it's not gonna be as powerful as when the wind is blowing as strong. So you need strong wind to do the job, because if we have a load at this point, just like when I connected this one right here, it was really hard for me to turn it. So if there is a load at this point, it's gonna need a lot of power at this point to turn this guy, because we are using because we need torque. We need speed to turn this guy at least a bit faster. Sorry, at this point, you see? Let's get this one right here. You see, a lot faster, but here it's a lot slower. The torque has been increased. The power at which it turns has been increased at this point. But when I turn it here, and I just stop it with one finger, you see? I'm gonna put a lot of force here. My veins are even coming out. So a lot of force, it's not turning. But I'm gonna hold this really strong. See? I'm holding this really strong, but it's still turning. See? So you can use a setup like this to build a robot. You can use a setup like this to build powerful robots, like a rover or something that can climb really big obstacles. This is really, really simple to build. All you need is just plastic to cut, or if you have a 3D printer, you can use that to print out this gear combination. Or you can go way more than that. You can go way more than that by creating a really big gear with many teeth. As you can see, we have this section going to the smaller section. A lot of teeth going here. We have, sorry about that. The first one has a bigger teeth, it has a lot of teeth, and the next one has lesser teeth. And then this one right here has more teeth, right? This one has smaller, just less teeth. And then that's what it does. As you can see there. Really simple. Turns. At this point, we have torque. really powerful. And at this point, look, just, I'm not even using that much force. You see, I'm not even using that much force here. I'm just placing my finger, just look. See, it's really hard. But look at this. I'm going to hold this really strong. I'm not even using that much force here, as you can see. Hold this really tight, but it's you turning. So, right. Okay, let's do something else. Let's do something else. Okay, in one of my videos, I talked about repairing a lithium-ion battery, just like this one's. Sometimes you're going to notice that the battery is not, there's absolutely no voltage. Sometimes you're going to notice that there's no voltage at all. So all you need to do is just, let's see, at the positive terminal, the battery has what is called a CID to protect it from overcharging. So what that CID does is that if the battery overcharges, the gases inside are going to build up, and then it's going to push the CID upwards, and then the CID is going to disconnect itself from the positive terminal, and then you're going to have absolutely no voltage. So all you need to do to repair the battery is just to use something like a screwdriver, a very slim screwdriver that can get through this holes, and then you just have to push it a little bit, and then you're going to hear a hiss sound like psst, to show that there was pressure, there was gases in there, and also that's also an indication that the CID has gone back to its normal position. So that is how I repair this lithium. So as for the LiPo batteries, the one that usually swell, the ones you find in your phone and in your laptops, you might find most of those in your laptop. So for those ones that are bloated, you see them swell because of over discharge and overcharge. So what you need to do is just put it in the fridge, and then what's going to happen is that the temperature of that fridge is going to create a suction in the battery, and then like just lessen the bloating in that battery. So that is how I repair most of this battery. But the thing is, if you do repair these batteries, you shouldn't use it to replace. You should only use it for maybe projects like maybe for emergency purposes. So you shouldn't go ahead and use it for to replace any a device or something. All right, so let's move on to the next thing. What should we do? Let's see. Let me get one of my projects so I can show it to you guys. Oh. All right, so this right here is just a module for listening to music. This is a radio, right? It has an SD card slot where you put your SD card to listen to music. So what I want to use this for is an audiobook. I want to use this to build an audiobook to play the Bible. Like I'm gonna download Genesis and then transfer that audio to a memory card and then put it in here, and then I'm gonna make this. I want to make it really flat. Like it's gonna be as small as this. Yeah, this battery. So the casing is gonna be as small as this battery, just the same size as this is. So we're gonna fit everything together and then maybe look for a battery that is this size, or maybe the battery is gonna be on top of that case. And then we are able to scan, skip, and pause. There's some buttons right here, and we can see the display. So I wanted to build this I wanted to build this devices and maybe give some out for free. And I mean, it might have some books of the Bible. Some might have Genesis, and some might have maybe I can even do the whole Bible. I can do the whole thing from Genesis to Revelations. I can do the whole thing just with this. Just gonna build an audio book, and then yeah, that would be nice. Control the volume. Each time you're free or each time you're working or something, you can just turn it on and then listen to any verse you want. Just skip, reverse, pause, and all that stuff. So yeah, that is what I'm working on. I'm gonna make a video on that, and also, I'm gonna have to bring that here, or I can just talk about it. All right, so let's see. I got some projects here in this book. Some things I've been working on. So I was called for a job and then a wiring job, and then I explained to the guy that I can do designs, like I can use bottles. I can cut bottles like wine bottles, bottles like this, cut them, and then do some sort of a kind of design where I just use an orc wood and just hang them with some chains and put some lights in it, different colors of light, and then hang them at the ceiling to beautify the place. So this was what I did, but I don't have a picture because I'm never mind. So let's move on to the next. I started a business of selling lights. I built and sold lights. Hold on a second. And then I moved on to pyrolysis, where I converted plastic into fuel. This was a drawing right here. So the first thing I got was crude oil, the crude oil. The first thing I got was crude oil. Then I then distilled that, and then I got just a bit of gasoline, but I got a lot of kerosene from that. And the plastic I used was HDP plastic because it's not as toxic as the rest of the plastics. Yeah, it's like, all right, that's the generator. I'll be back. Let me get some. My back. Oh. All right, let's just do something else. Breadboard. There's a lot of people that don't know how to use stuff. All right, so I'm gonna show you a really simple trick, or maybe simple and how to use it. So how this works is just we have two separate conductors to just line up like this, straight line, two separate conductors, and then this one's right here are not connected together. This one's separate, but they're in line. Let me just hook up my multimeter, so I'm going to show you exactly what's going on. So way to really understand this is to use your multimeter to tune. You're just gonna have to tune the knob to the continuity, and then right. So this is probably not gonna get in, or else I'm gonna damage it. So I'm gonna use this wire. All right. I'm gonna use this. Come on. Right. So that's continuity, right? Okay, so let's see. As you can see, and peel this out. Peel this out and then hook it up back again. Back again. And then, as you can see here, we got the it's reading at this point. So let's see if this one is. So we have no connection from here to this point. So the connection just only stops here. And this as well is not connected to this. So it's on its own. So each of these guys are on their own. It goes with every single thing here. Each of them are on your own. But as for this one, let's see. All right, hook this up. As you can see, let's try this line. This isn't, is it connected? No. Wait, hold on a second. Let me put this in well, so we can get a good reading and stuff. All right, peel this. All right, put it in there. All right, so let's, oh, come on. Connect this again. All right, so we got readings. Same here, a little bit, let's check up. No reading. Okay, so we've got a mark here which says that it stops only here. So this very one right here is connected in line with this hose to this point where it says it's stopped. So this has no connection with this. This very one here has no connection with this. This does the same thing as this one is. So the line is just straight up to this point. The connection is straight up like this. It has nothing to do with this guy. It's not connected to this. None of them. These guys are separated from each other. And so, I mean, that's just a simple way of understanding this guy. So what I'm doing is, so we got 39 viewers at the moment. So what I was doing is I was talking about how I'm gonna build this generator, a wind turbine with this setup. This is just a DC motor, and then we've got gears. All right. Hey, I didn't see that. What's up, Roberto? Well, I had no idea someone was commenting. Okay, something, knowledge, the generator. What does that mean? Oh, okay, you want to see the generator. Okay, so, this is it. This is the generator. This right here is the generator. And this is the same thing, and this is what is inside the generator. Right? So we've got gears, we've got 3 gears, same thing here on the inside, and then we've got this DC motor as well. So what happens is when I spin this, when I turn this, which is this, it makes this one go fast, and then it turns the motor really fast. So, and because the motor is really fast, we can get up to 30 volts. So let's measure that again. Okay, I'm gonna connect this and connect the generator. All right, turn this really fast. 33 volts, DC. So it's not AC, it's DC because it's a brush motor. So it's only the brushless motor that's gonna generate AC voltage, which is much more better than this one's, because you can rectify it and get just the right thing voltage you want. Okay, so Roberto says that with load it doesn't work. Okay, let's try that with a load. Okay, yeah, okay, let's try that. Let's use this to power this 12 volt fan. This is a DC fan. So I'm gonna hook this up, and then, yeah, it does work, but you're gonna need a lot of, you're gonna need a lot of power to do the job. So let's just hook it up and show you how it is. Okay, so this is it. Place that right there. All right, so put this up so you can see it's actually spinning and blowing air. As you can see, it's working, but it's kind of hard. All right, place that here so you can see. It's really fast though. All right. Okay, let's again. All right, so as you can see, it works, but it's really hard because, but it's gonna work much better if I hook up a wind turbine blade and stuff, or maybe I can make it much better by doing creating my own gears. I mean, something much bigger than this, but only two of it. And also, I'm gonna buy maybe a car alternator is not gonna work well, but a permanent magnet alternator is gonna work perfectly well. But those are really expensive. There's this one that's being used in a washing machine. The inverter washing machine. It has permanent magnets in it, so it's going to work perfectly well, and also it works at a really low RPM. So if you turn it really slow, it starts generating AC voltage, and it's really effective, very effective. And it's got thick coils on it, so you're gonna get a lot of amp from it. So okay, let's measure the current again so you can see what's going on. All right, I'm gonna tune this to 200. All right, place that there, and then all right. Okay, guys, so I'm gonna hook this up right now so you can see exactly what's going on. All right, that's really hard. Let's see if we can get up to 1 amp. No, we can't. That's really hard. Let me use this screwdriver. There's a hole here. I'm gonna put that inside. All right. Oh yeah, we did. Yeah. Whoa. No, I put it in the wrong. Okay, it's supposed to be here. All right, so yeah, so we've got 1 amp. Wow, that's really good. We've got 1 amp. We've got 1 amp, guys. Right, so yep. I'm gonna call it a day, and then some other day we're gonna do something much better. So goodbye, guys. Thanks for watching the video.